Hey, JP here. Here's one from the archives. Away 97 and 98 were high-altitude balloon flights carrying over 700 student experiments, a dozen industry payloads, and a few of our own. This is a highlights video from launch to landing of both vehicles. This video is from a longer video that we sent to everyone who'd flown with us on this mission. We flew them back on May 4th, 2014 from Area Trombone in northern Nevada. Enjoy. The team arrived at the site the evening before and set to work on prep. Lots to do. The night before, we set up the balloon launch bags, the generators, awnings, and the antennas. Science on the inside and art on the outside. In the morning, we start vehicle checklists. I love the walkout. The different teams are in the zone and you're rolling to launch. Every 30 seconds, the vehicle transmits down its position, including altitude, along with system status. We were flying in the middle of a warm front. Most of the time, in a warm front, the sky is pretty hazy up top. When there's a cold front, the sky is crystal clear and the view is spectacular. The trade is that it's very gusty on the ground and hard to launch the balloons. We get some pretty fast high altitude winds in the spring. The vehicle was moving at over 100 miles an hour at one point. All during the flight, I'm constantly bugging the mission control team with, "What is the climb rate?" The gray deck paper has come unstuck from the deck and is starting to flap around. It's so bright at high altitude that the big white deck can dazzle out the cameras. We glue down gray paper to cut down on that. During descent, Mission Control is giving position updates to the recovery team. They are comparing the descent path to the forecasted landing site and looking at Google Earth and physical maps, getting the plan together. The recovery team won't head out until about an hour after landing. We used to pre-stage the recovery team and then have them in chase mode, but we found that recovery is faster if you wait till after landing, verify multiple position sources, and spend the extra 45 minutes going over, discussing, and arguing all the different ways until you have a solid plan and then executing it. Away 98's balloon popped early at only 67,011 feet. We had a collect climb rate, so no overfill. It was likely a flaw in the balloon. Away 97 was still climbing. It was now up to away 97, to go high. Now for Away 97. That clicking you hear is the still camera that is mounted on the same rack as the video camera. When we're flying a pair of balloons, we like to launch them together. That way, they'll land generally in the same area, making it easier on the recovery teams. Away 97 is the one on the right. Now we're switching to one of the onboard cameras. These are mini cubes. These mini cubes were made by middle school students all the way up through professional engineers. My favorite is in the one in the middle with the marble on top. It's a sample return mission trying to sample the biology at the edge of space. It was made by junior high school students. In the morning, the sun is at a low angle and lights up the deck. When noon arrives and the sun is overhead, the deck is in the shadow of the balloon and dark. At 100,000 feet, the bright is really bright and the shadows are really dark. This is so important when we're shooting a TV commercial at the edge of space, or we just want to get the filming right. Now you can really notice how the gray deck paper cuts down on the glare. Up top, where all the payloads are busy doing their experiments and gathering data. On the deck below that you can't see, there are 300 additional PongSat student experiments. All told, there were over 2,000 students, engineers, scientists, and artists flying with us that day. Here, the vehicle is exposed to cosmic rays, extreme temperatures, near vacuum. For some, this is a trial for future space missions. For others, this is where they want to be. Again, in slow motion. Away 97 made it to 98,944 feet. We measure that with 4 onboard GPSs. two are satellite uplinks. One is part of the direct telemetry system, and one is part of the onboard recording data logger, our black box. You can tell the parachute has deployed by watching the shadow of the parachute back skid on the deck. Before it was solid, covered by the parachute. Now you see a grid pattern of holes. That's a chunk of balloon that has fallen on the deck. Both craft flew 60 miles downrange and were recovered the next day. We're now at 200 missions flown and getting ready for the next flight season. Be sure to hit the subscribe button so you don't miss our next mission. Thank you for watching.